All right, class, this is a review over solving limits algebraically. Remember, the very first step is to always just go ahead and evaluate, see if the function exists at that point. And this is fairly common. Boom, we're going to get a 0 minus 1, and that is going to simply equal a negative 1. Therefore, the limit value is going to equal negative 1. This makes sense because this function, 2x minus 1, is simply just a linear function, correct? So as we approach 0 from both the left and the right, we are approaching that y-intercept of negative 1, okay? But algebraically, all we have to do is simply plug in, okay? Very easy. Now, sometimes when we plug in, like for instance this problem, let's plug this in. I'm going to say 0 to the 4th minus 5 times 0 squared all over 0 squared. Well, this is just a whole bunch of 0 over a whole bunch of more 0. But remember, class, if you get a 0 over a 0, you're always saying, oh no, because that means you have to do some more math, correct? All right, so what we can do with this problem is we can try to factor and cancel and see if anything works out, okay? So I'm going to look around here and I'm going to say, well, what if this limit of x approaches 0? What if I manipulated and I noticed I had a common term and I took that common term out? Well, good things would happen because we notice we have an x squared over an x squared, which is great because that's just 1 over 1. That will simply cancel. So we've really simplified my limits. I now have the limit as x approaches 0 of just simply the equation x squared minus 5. Like the one we saw earlier, this is a plug-in. Okay? We can just say 0 squared minus 5, and what do we get as our answer? We get a negative 5. Okay? So a little bit more steps involved, but same concept, same process. Just got to cancel something out. All right, let's see what happens when we come over here. This problem, man, a whole bunch of fun stuff. First and foremost, go ahead and evaluate. I'm going to have 1 over 3 plus 0 minus 1 over 3. Well, I already see the potential, all divided by 0. Again, 1/3 minus 1/3 is 0, but hey, oh no, that means we have to do some more math. That's okay, we like math. So, in the summer packet, we saw lots of problems where we had to work our algebra skills. And right here, I see a fraction minus a fraction, so why don't we just go ahead and give this guy a common denominator by multiplying by each other. Now bear with me, let's see what happens. So 3 times 1 is, of course, is 3. And then we have a minus sign. And then 1 times that is just all that. So 3 plus x. And then now our denominator, I'm just going to leave it very rustic looking. And just say 3 times 3 plus x. That's all it really is, correct? And the whole thing is still, don't forget this x, the whole thing is still being divided by x. Okay? Well, let's take care of this. I have a negative sign, so distributive property tells me to kind of move it over. So now this says the limit as x approaches 0. Well, this is now 3 minus 3 minus x all over 3 times 3 plus x, all divided by x. Right away, this 3 minus 3, that's fantastic. We can get rid of that. But I'm still a 3-story fraction, and I don't like 3-story fractions, so I'm going to kind of reduce this. You guys think that's a good idea? So we have the limit as x approaches 0 of negative x over 3 times 3 plus x. And dividing by this x over here is the same thing as multiplying by 1 over x. Do we agree? Dividing by fractions, easy as pie. We're just going to flip the second and multiply. So again, dividing by an x is the same thing as multiplying by 1 over x. Well, when I write it this way, it looks really pretty because I can cancel out an x and an x. But don't forget I'm left with a negative sign. Okay? So this simplifies down to the limit as x approaches 0 of negative 1 over 3 times 3 plus x. I've done a lot of math and a lot of simplifying and canceling. Let's go ahead and reevaluate. When I plug in, I'm going to have a negative 1 over a 3 times 3 plus 0. This is good news. 3 plus 0 is just 3. Don't forget this 3. My answer is negative 1/9. Okay? So, 3 examples of algebraically solved limits. Choose your poison. You can solve them however you like. Some you have to simplify. Some you can just plug in. But ultimately, you're all going for the same goal. All right? Feel free to comment, share, like, subscribe, all of the above, and I'll see you guys later.